All right, what's up, guys? So today is going to be today's little webinar is going to kind of be part one of I would say three, and it's going to be kind of going over a little bit of what I'm looking into my master's thesis and what is my research topic looking at. So just to give a little bit of context, a lot of the influence for the reasons why I'm doing my research come from both Christian Thibodeau and Charles Poliquin. So Charles was the first one to make an association between the brain and personality, as well as exercise performance, more specifically strength and conditioning style. So Charles used the Braverman nature assessment. I'll be talking about these in following videos, but Charles used the Braverman test, as well as some Eastern philosophy regarding the different personality types, to pretty much like determine some different training variables. So, for example, in the Braverman assessment, it looks at neurotransmitter dominances, and let's say for a dopamine type, they may respond better to higher intensity training. So that's kind of how it seemed like he was utilizing the test. And then Christian took it a little bit further, taking some of the principles and expanding on it and making it, I would say, a much more in-depth assessment. And he developed a neurotyping system, which essentially, once you take the test, it classifies you as one of 5 neurotypes, which is characterized by a neurotransmitter or an excitatory neurotransmitter dominance, as well as an inhibitory neurotransmitter dominance, which is one of the reasons why I find his system more, let's say, complete, because it's looking at both the excitatory and inhibitory side. And then based off your neurotype, you are theoretically more suitable to certain levels of volume, or certain intensities, or certain training styles. So what my research is looking at is basically the concept of post-activation performance enhancement. So it basically talks about how, or refers to how, a conditioning activity or exercise potentiates or improves subsequent voluntary performance, typically seen in testing for vertical jump, or any jumping ability, as well as sprinting ability. Mainly, those are the main tests focusing on, let's say, sport athlete. So my research is looking at how these neurotransmitter assessments through personality questionnaires, how that may influence, let's say, the effectiveness of PAP. So in the PAP literature, there's a lot of, let's say, variety in conclusions. But the one main thing that research seems to agree on is the fact that PAP is highly dependent on the individual. There is no consensus regarding optimal conditions or protocols. So there's research showing that higher intensity is better than medium intensity, and vice versa. There's issues with rest intervals, whether it should be short, how long is the potentiation last for. So there's a lot of confusion. However, I did read a research, I believe it was by Batista and Al in 2011, that talked about the potential effect that the conditioning activity has on the psychology of the athlete. So it seems as if there's a psychological benefit of performing exercise, and it's not necessarily purely the muscle physiology that is responsible for improved performance. So I'm looking at neurotransmitters and personality assessments and its ability to determine the effectiveness of post-activation performance enhancement. But just to kind of give a little brief, let's say, neuroscience background, so that you might understand some of the concepts later on in other videos. I'm just going to be outlining some of the neurotransmitters that are involved with the assessments as well as exercise performance. So if you're not familiar with neuroscience or physiology, you might not be familiar with neurotransmitters. So neurotransmitters are basically chemical messengers that transfer information from a neuron to its target. So think of it as just, it's relaying information from the brain to different parts of the body. The most popular one is called the neuromuscular junction. So it's essentially where the motor neuron connects to or relays and signals the muscle to contract by releasing the neurotransmitter acetylcholine. So acetylcholine is released by the motor neuron. It binds to its receptor on the postsynaptic membrane, and that, through a cascade of events, initiates a muscle contraction. So the 5 neurotransmitters that my research primarily looks at are norepinephrine or noradrenaline, dopamine, acetylcholine, serotonin, and GABA. And I'm just going to quickly go over each of the neurotransmitters and some of their functions or relation to exercise. So norepinephrine is very much involved with increase in arousal or energy. It has also been shown to increase skeletal muscle contraction, as well as increasing the mobilization of energy. So it's what you'll see is that it's very similar to dopamine in that they both have an effect on arousal and energy. But the way that I kind of distinguish the two is that norepinephrine seems to have a large effect on the actual musculature, or let's say the skeletal muscle physiology. Whereas dopamine, while increasing arousal, also increases motivation. So dopamine seems to be more so related to how the brain functions during exercise, and not necessarily having a direct or a very strong influence on how the muscle functions during exercise. Acetylcholine has been shown to be related to increasing the speed of transmission of neurons, as well as increase in focus and mental performance. So I believe in another video, I'll be talking about attentional performance. But acetylcholine is also primarily known for its involvement in signaling muscle contraction and primarily being released in the neuromuscular junction, as I mentioned before. Serotonin is an inhibitory neurotransmitter, but the way that I kind of view serotonin is more as a modulator. So I believe Christian used this example as well in his neurotyping course, but serotonin is like a dimmer. All right. So its levels are increased during times of increased norepinephrine and dopamine in order to kind of quiet those systems down as a means to prevent hyperarousal or a state of anxiety. And this is seen during exercise and describes the central fatigue hypothesis. So the central fatigue hypothesis basically states that with an increase, let's say in exercise duration or intensity, there is an increase in serotonin levels and a decrease in dopamine levels. Now, if you look at, with the view as serotonin as a modulator, it makes a lot of sense. With the increase in serotonin, it acts on the dopaminergic system to kind of, quiet it down so that you don't, have or aren't too aroused after exercise. With the decreased dopaminergic activity and the decreased dopamine levels, as well as the increased level of serotonin, an inhibitory neurotransmitter, there is an increase in fatigue, as well as a decrease in skeletal muscle force. And then also, finally, there's an increase in perception of pain associated with increases in serotonin. Finally, GABA. GABA is your classic inhibitory neurotransmitter. So if serotonin is the dimmer, GABA is an on and off switch. Okay. It has been associated with increasing levels of fatigue and having sort of like a sedative effect, or increasing relaxation. So people with who are maybe prone to anxiety-like behavior may be given supplementation to boost their GABA levels to decrease their levels of arousal. So some little notes that are pretty interesting. Dopamine and norepinephrine are very similar due to the relationship. So the functions are very similar, that they both increase arousal as well as energy. And this, I believe, comes primarily because they are very closely related. So dopamine is actually a precursor to norepinephrine, which norepinephrine then gets converted to epinephrine or adrenaline, as it's most commonly known. And then finally, there's an interesting relationship between acetylcholine and fast twitch muscle fiber contribution or percentage. So with an increase in fast twitch muscle fibers or a greater percentage, there's an increase in acetylcholine receptors as well as an increase in acetylcholine content. This primarily happens because there's a greater density of these junctional folds. So there's a greater surface area for these acetylcholine receptors. So what you'll see, and it makes more sense later on, but I'll hint towards it now, with more of an acetylcholine nature or a dominance, there may be a correlation to, let's say, those being more acetylcholine dominant and having a greater percentage of fast twitch muscle fiber. Again, I haven't seen research looking specifically at this, but it's a potential theory that may hold a little bit of value. But until research comes out and says or confirms the theory, it's still only a theory. But that covers the basis for the neurotransmitters and covering the different neurotransmitters that are important for exercise performance. So I'm going to cut it there. And then in the next videos, I'm going to be talking more about the assessments of neurotransmitter dominances and how they may relate to the neurotransmitters. So if you guys think this is interesting, stay tuned for the next 1 or 2 videos, because that's when things really start to pick up and things start to make sense. So I hope you guys enjoyed, and I'll see you guys next time.